think, to talk, to work together, and to grow in our knowledge and understanding of equitable mathematics practices. And so for today, I want to just give a special warm welcome to our guest, Dr. Robert Q. Berry III. Dr. Berry is the Samuel Braley Gray Professor of Mathematics Education and the Associate Dean of Diversity, Equity, and Inclusion in the School of Education and Human Development at the University of Virginia, and the immediate past president of the National Council of Teachers of Mathematics. Berry co-edited the 2020 book, High School Mathematics Lessons to Explore, Understand, and Respond to Social Injustice, which focuses on teaching mathematics for social justice. And he has published over 100 articles, book chapters, and proceedings, and has given over 200 presentations. 201 now, today. His articles have appeared in the Journal for Research in Math Ed, Journal of Teacher Education, Educational Studies in Mathematics, and the American Educational Research Journal. Berry is a two-time recipient of NCTM's Linking Research and Practice Publication Award, has also received the University of Virginia's All University Teaching Award in 2011. And Dr. Berry, we're just thrilled to have you here, excited to hear from you today. So welcome, and I'll turn it over to you.
All right. Thank you for having me. As soon as I start talking, my dog starts barking. All right. So you may hear a dog in the background. So let me go ahead and get my screen going here. I want to share my screen. And let's see. Hopefully you can see my screen. Let's see. And let's get into presentation mode. All right. Are we good there? Oops. We're not good there. It was good. All right.
There.
I'm sorry?
That looks great.
All right, good. Good. So, as Paul said earlier, I am Robert Berry, and I am a professor at the University of Virginia, as well as an associate dean. But tonight I want to talk about unpacking equitable mathematics teaching practices. But before we get started, I actually want to do I live in Charlottesville, Virginia, and if you're familiar with Charlottesville, let me just kind of give you kind of the lay of the land here. Charlottesville is situated in central Virginia. If you're in Virginia, it's kind of shaped like an isosceles triangle. So I acknowledge the Monacan people as the traditional custodians of the land in and around Charlottesville, Virginia, and pay respect to their elders, past and present. My acknowledgement of the Monacan nation reflects a commitment to a culture of inclusion and respect that begins with those who were here first and whose continued presence is important to our future. I also would like to acknowledge the work in the individual lives of the enslaved Black people who built and sustained the everyday life of the University of Virginia. Scholars estimate that at least 5,000 enslaved Black people worked on the grounds, with many in residence, starting with the construction of the lawn in 1817 and lasting through the end of the Civil War in 1865. These acknowledgements are a critical public intervention, a necessary step towards honoring the Monacan nation and enslaved people, towards enacting the more substantial project of decolonization and reconciliation. And so on the screen there, you see the Monacan nation's shield, as well as a representation of the memorial to the enslaved laborers at the University of Virginia. Actually, the memorial is completed, and it just has not yet, been, celebrated because of COVID. It was supposed to open in April of 2020, and it is actually open now, but has not had its official opening just yet. So I want to start off with a couple of things, and I'm going to borrow from my colleague Crystal Kalanick-Craig, because the plan for today is we're going to do 2 math tasks, and then we're going to talk about instructional routines that are embedded in those tasks. And as we talk about those instructional routines that are embedded in those tasks, we're going to unpack the equitable teaching practices that are embedded in those tasks. So I'm starting off with my colleague Crystal's work, Kalanick-Craig's work, as she talked about this idea of the rights of the learner. And she describes 4 rights of a learner. And let me just unpack these for you. because I see these rights as being norms and how we can have normative spaces in our classroom that intersect with equity as well as mathematics teaching and learning. So the first right of the learner is you have the right to be confused and to share your confusion. Although you have the right to be confused and share your confusion, you also have the responsibility to bring clarity to your confusion. That means that you have to engage your classmates, you may engage your teacher, and may engage others to understand where your confusion may lie. Secondly, you have the right to claim a mistake. And just like you can claim a mistake, you also have the responsibility to understand why your mistake was a mistake. So if you claim a mistake, you then have to figure out and working again with classmates and others to understand why that mistake was a mistake. You have the right to speak, listen, and be heard. Too often in mathematics classroom, those who speak are often positioned as the competent ones. So I want us to give space to those who don't often get to speak so that they can be heard. So we have the responsibility to give space to others so that they can be heard. We have the right to speak, listen, and be heard. We also have the responsibility to give space to others. You have the right to write, do, and represent only what makes sense to you. And this is about mathematical representation. And because you're writing and doing and representing what makes sense to you, you have the responsibility to make sure that to explain to others why that makes sense to you. So these are our 4 rights. With these rights, there come responsibilities. And within these rights and responsibilities, I hope they set up the normative space for our interaction today as we engage in a couple of mathematics tasks. Are we cool with that? Great, 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 great. So I just want to talk a little bit about some work I've done here in my local area. It's going on 13 years now. I founded a program called Math Men in Mission. And Math Men in Mission is a collaboration between my university, 100 Black Men of Central Virginia, where we founded a program called Math Men in Mission. We actually call it MQ. The MQ program is one of those spaces where we try to create spaces for additional learning opportunity for boys who identify as Black. And from this work, I contend that teachers are identity builders. And because teachers are identity builders, we have the power to position learners as being mathematically and socially competent by creating time and space for learners to demonstrate their agency. So I think mathematics classrooms are mathematical spaces, but they're also social spaces. And the way that we build in the social spaces, I think we build it in through the kinds of tasks that we create for students to engage. So I think we create tasks, if we create tasks that are grounded in social interaction, I think we find ways for students to connect to one another. And I also think we find ways for students to connect with the mathematics. So it is kinds of tasks that we take discretion. Teachers have a lot of discretion. We take up a lot of discretionary space. And when we take up discretionary space, that means we make decisions about what happens and what happens and what do not happen in our classrooms. So I'm going to invite you to take up this problem, and it's called the orange problem. So if you don't have something to write with or something to write on and write with, I'm going to give you 7 seconds to figure that out before I present the problem to you. Are we ready? Here we go. Here's the orange problem. So I'm going to read it aloud because I want to unpack it, and then I'm going to give you an opportunity to read it to yourself. A grocer was asked, how many oranges had he sold that day? He replied, my first customer said, I'll buy half of your oranges and half an orange more. So that first customer came in, he saw the orange stand. He says, I'll buy half of all the oranges there and only in half an orange more. He then said, my second customer said the same thing. I'll buy half of your oranges, so the half of the remaining oranges, and then half an orange more. He then stated, My third customer said the same thing. I'll buy half of your oranges and half an orange or more. When all three orders were filled, he was sold out and did not have to cut a single orange all day. How many oranges had the grocer sold in all? So I want you to think about that. So in the chat, if you don't mind, just jumping over to the chat, just drop in. What do you notice about this problem? What do you wonder about this problem? Your notice can be something that anything that you notice that might stand out to you. And your wonder could be posed as a question. So I just want you to drop in the chat your notices and your wonder. So I'm going to give you an opportunity to just drop in the chat your notices and your wonder. Feel free to do that. How many oranges did he start out with? I see. So that's one that's come up. Any other notices and wonder? I wonder if he started with an odd number of oranges. How can he sell half an orange without cutting orange? I wonder why you would buy half an orange. Half an orange without cutting. I notice there's always an extra addition of purchased oranges. All customers bought half an orange. How did they not cut an orange? All right. Same, half an orange. So that comes up. All right. Great. I wonder if the oranges were not already pre-cut. So I'll answer that question for you already. So the oranges were not pre-cut. All right, let's move forward. I'm going to give you a little think time. I want you to work on this problem. I'm going to give you just a little bit of think time. I want you to work on this problem. I'm going to give you probably 64 seconds to work on this problem. You can draw pictures, you can do equations, you can create tables, you can represent, you have the right to write, do, and represent what makes sense to you. You have the right to write, do, and what makes sense to you. All right. So I want you to stop where you are. I don't expect you to have an answer. And if you do have an answer, please do not share your answer. We're focusing on your strategies. We're focusing on your thinking. So if you have an answer, please do not share your answer. We're going to go into breakout rooms. I'm going to give you a couple of minutes in your breakout rooms. What I would like for you to do is we're going to engage what I'm going to call rough draft talk. And rough draft talk is just what it sounds like. You're sharing your strategies, you're sharing your thinking, you're sharing with your colleagues what you tried, what worked, what didn't work, but you're not sharing solutions. You're sharing strategies and you're thinking about the task. There's no expectation that you have an actual solution there, and you may not have a solution, but if you do, really just focus on your thinking here. And then, so we're going to break out right now. So we're going to break out into breakout groups. And if you're ready to break out into breakout groups, let's go ahead and jump into breakout groups. And I'm going to lean in on Paul a little bit to see if we're there.
All right, we'll go for it. You want 3 to 4 minutes or so?
Let's go 3 minutes. 3 minutes.
All right, perfect.
Again, here we go. So the one thing I love about rough draft talk is if we label it and tag it as rough draft talk. I explicitly tag rough draft talk as a way of positioning one's thinking in progress, because there's no expectation that you have a solution. It creates an opportunity to think for one thinking in progress. It reduces the threat of being right or wrong, because students are sharing their ideas, they're sharing their thinking. And so there's no pressure of being right or wrong, or there's no threat of being right or wrong. It also promotes the idea that we can refine our ideas, because you can imagine that students, as they interact with one another, they might say, oh, I really like that idea. I'm going to try that strategy. So they're now in this metacognitive space where they're trying out or thinking about one another's strategies. And so they're thinking about not only their idea, but someone else's idea in this metacognitive space. And then finally, I think it expands what counts as a valuable contribution. When we say a valuable contribution, because, you can just guess. The idea of guessing, and then you learn. I think of guessing as hypothesis testing. You try something out, you learn something, try something out again, you learn something, and these things kind of arise from one another. So anybody want to unmute themselves and share a thought that you had from your group? And just unmute yourself and say something. I'll sit and listen.
Sure. Initially, my gut feeling was to start with a random number and work my way down to 0. But then after a few seconds, I realized we're going to end with 0. So I think it just kind of made more sense to start with 0 and kind of work my way backwards. And so.
So you start with 0. So when you started with Mario, right?
Yes,
Mario,
sir.
When you started with 0, what did you do?
Well, I was like, well, how can I get to 0? So my natural reaction was to test out an odd number. So I figured, well, let me see what happens if I had 1. Half of 1 would be half an orange, plus another half would make 1 whole orange. So the previous step of that would have to be 1 orange. And then, okay, so 1 would work there. And then I just kind of said, okay, well, what can I work from to get back to 3? So then I was like, well, let me try 3 and then half of 3. And so I just kind of started working backwards to get to where I began from the end.
Anybody else want to share something that they've learned from their group? Come on, I know there's got to be somebody else.
We said that we figured out it had to be an odd number when you start, because in order to divide it by 2 and have a whole number once you subtract the other half, you had to start with an odd number.
One more person. Anybody else want to share? Okay, so one thing I want us to think about is that idea of rough draft talk as a strategy, as a structural routine, and what it affords us as students interact with one another. So one of the things I learned from when I work with my boys, one thing that they shared is that there has to be an odd number. And so when we did our rough draft talk, that was one of the things that they shared out. There had to be an odd number. And as I heard with this group, one of the boys said, well, the last customer will get 1 orange. And so the justification, if there's 1 orange left, I'll buy half of your oranges, which is, if there's 1 left, that's half an orange and half an orange more. That means that person took the whole orange. And then this one just kind of gave it away, right? So this person says, if the last person gets 1 orange, then it's times 2 plus 1, whatever that might mean. But nonetheless, it's just kind of thinking through this. I want us to focus on the kind of the strategy, the instructional routine. So the idea of rough draft talk may prompt some thinking. It may prompt some strategy. It builds in the socialization. And that's the thing that I want us to think about. How do we build in socialization where students are connected to each other and connected to the mathematics? So here's one way one student represented. They figured out, that, hey, there's 7 oranges, right? So a guess and check strategy. So if you look at this representation here, you see they said, if there's 7 oranges, I'll buy half your oranges, which is 3.5, because you can see where this line is, 3.5, then half an orange more, which means that first customer bought 4 oranges. And that leaves that there are 3 oranges left, right? So the second customer comes in and says, I'll buy half your oranges, which is 1.5, and then half an orange more. That means that the second customer bought 2 oranges. And then the third customer comes and says, I'll buy half your oranges, and then half an orange more. That means that the third customer bought 1 orange. But let's look at this differently now. What if we kind of do a different representation? Now we put this into a table, right? And what if I would ask, suppose there were 5 customers, suppose there were 10 customers, suppose there were any number of customers, how can we then generalize this? One of the things that we might consider is, how is this representation of the circles connected to the table? And where does it show up? Anybody want to unmute themselves and make some connections? You see any representation between the drawing and the table? Yes.
Looking at the table reminds me of an activity we did with, oh man, was it Miss Rizzo with the fun win little sequencings? One, like the sequence squares. I'm not sure if you know who fun win is.
I do.
But
I
it's
know
like the
Fawn
two,
very
the-
well.
Like an end power. There has to be something minus or plus one. Thinking -1.
Okay. Well, let's keep working. Let's keep working through this. Another way of thinking about this, you remember that 7, so we have 1 customer, 2 customers, 3 customers. We know that if there are 3 customers, there had to be 7 oranges in the store to begin with. And there's something interesting about this 4, 2, 1 here. And there's something interesting about this 2, 1 plus 2, or I'm going backwards, 2 and 1 and then 1. But then I look at this representation here. I'm wondering, where can I see the 1? Where can I see the 2? And where can I see the 4? And if I look at the 7 customers, and I hope that we can see the connection between the 1, the 2, and the 4. And I think we can see that connection if you look at the number of oranges that are circled in the picture here. And so there's something interesting about this. If I look at the diagonal, look at the diagonal on the oranges per customer. 1, 2, 4. You look at 7, 1, 2, 4. There's something interesting about that as well. So there's something interesting showing up here. And I continue this, and now I'm asking these questions, right? And so what I love about this task is I'm building into socialization through rough draft talk. I think this task can be used with younger students. I think this task can be used with older students as we begin to unpack and look at patterns that are there. We can look at representation. We can look at problem-solving strategies, because now I'm still looking at this 1, 2, 4, 8, 16. There's something interesting about that as well, because now I have 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and there's something about this 1, which is 2 to the 0. And so I wonder what that means, and keep on going there. I'm still exploring patterns, and I don't remember the person who said that plus or minus 1 something, but we see this kind of interesting pattern that shows up. And what I want to kind of think about is the instructional routine that I talked about with rough draft talk and the affordances that it offers us. But also, I'm going to argue that math occupies a privileged space in our curriculum. Knowledge of mathematics is actually used as a proxy for intelligence. And we think about a proxy for intelligence to access higher level math courses. It's a gateway for academic and economic opportunity, and all of those things that we think about, progress. And so how do we create spaces that math becomes socializing spaces? And that is, when I think about instructional routines, I'm thinking about instructional routines that are socializing spaces and the socialization that comes with that. So because of the privileged spaces, I think we have to, there are disputes that happens in these privileged spaces about pedagogical approaches, content, types of assessment, equity and inclusion. All of these things show up. The hierarchy in schools that happen around that reproduces race, gender, and equities and other hierarchies within our schools. So I want us to think about how these things how can we use our instructional routines or our teaching practices that might have some impact on the negative hierarchies that show up in the privileged spaces of mathematics. So we're going to do another task, all right? So here's another task. I hope you're not familiar with this task. This is a very common task. Some of you may have seen this task before. If you have, please give me some grace. All right, I'm going to show you a picture. I just want you to write down all the things you notice in this picture. Are you ready? Just write down all your notices. Just write down all the things you notice. Ready? Here we go. What do you notice? So I'm just going to stop a little bit because I'm just looking at my screen. And can I just call who's on my screen? Daniel Jones. You're right beside me, so I'm going to call on you. Daniel, what do you notice in this picture? What do you know? Just write that. Tell us a couple of things that you noticed in this picture.
All right. So the first thing I wrote down was that there's 5% battery left. Second thing I wrote down that there's two congruent rectangles.
Okay. All right. You notice anything else?
Yeah.
Keep on going.
I noticed that there's no year. I noticed that it's nighttime. I noticed that the phone is charging.
How do you know it's nighttime?
Because of the moon.
What does that moon mean?
I assume it means nighttime.
All right. All right.
Okay. And then I noticed that it's close to a square and that the internet reception is low.
All right, cool. Anybody else want to add to Daniel's notices? I can go down. I see Corey Love. You're right under Daniel on my screen. So Corey, I'm calling on you.
Yeah, okay. I noticed it looks like the alarm clock, so maybe the alarm set.
How do you know the alarm is set?
I think that clock up at the top means that the alarm's set.
All right.
I think.
What do those other symbols mean?
Yeah,
Corey?
the one next to it, I noticed that it's connected to Bluetooth, but I did not remember it's charging as well.
How do you know that?
Because it has the lightning symbol.
Okay.
And I could not remember what the little kind of arrow means, the one in between the moon and the alarm clock. I couldn't remember what that was.
All right. What does the moon mean?
I assumed it meant it was nighttime, but I didn't know that for sure. Maybe it meant sleeping. I don't know.
I see Dylan Grimes shaking his head.
I don't really know what it means. You know what kind of I kind of thought it was nighttime too, but I'm not really sure.
That's all cool. Dylan, you want to add to that?
I've had to turn this on many times because my Mac for school is connected to my iCloud account. The moon means do not disturb. And the arrow is location services.
Cool. So here's the thing. All kids can notice. And what I want to do before I engage in a math task, I want to invite the kids in on the socialization of this. Because imagine, we're not yet doing math, but I want to raise the engagement. So I want to lower the risk taking, because participation is a risk taking event, right? For kids to participate in front of their peers, whether virtually or not, they're taking a risk. So how can I create a structure so that kids can feel like they can be participatory, lower the risk taking, but invite them in? We haven't gotten to the math yet. We're going to get to the math, but I want them engaged so that when we get to the math, they are invested in the task. They are invested in the task. All right. So we haven't done math yet. We noticed a lot of things. Did anybody notice it was 7-Eleven day? Get your free Slurpee. All right. All right. So here's my next one. I'm gonna show you the same picture. What do you wonder? And your wonder could be a question. What do you wonder about this? It can be a question. It can be a thought. So what do you wonder? And I'm going to call on Carly Youngman, because Carly, you're next on my screen. So Carly, do you have a wonder or question about this picture?
I said, is it 9:02 a.m. or p.m.?
Ah, so you wonder if it's day or night. Ah, Carly, you have any other wonders?
What year is it?
What year is it? All right. All right. Is it Donato? What do you wonder?
That's correct. I am wondering about the 3 circles at the top, as I'm assuming this is probably like an iPhone, and I'm not familiar with iPhone, so I'm wondering if that's the amount of pages probably on the screen is in their screen, maybe.
Andra Booth. Am I right, Andra? Is that correct?
Yes.
What do you
Yes.
wonder?
I was wondering what happened on this long looking Friday that the battery is drained all the way down to 5%.
Wow. How many people are like me? 5%, I'm still good, right? It ain't dead until it's dead, right? All right. So how did that phone get to 5%? Anybody else have a wonder? One more wonder. Let's see. I'm going to call on Amanda Morris. Amanda, what do you wonder?
I was wondering why, hang on, sorry. My roommate's right next to me on the same Zoom call. I was wondering why they didn't turn on their power saver mode when they hit 20% on their battery.
Again, notice the socialization part of this and how the socialization gets students invested. Now they're connected to the task. We haven't done any math yet. I want the investment first, and then we'll jump into the math. So we've done our notice, we've done our wonder. And so here's what, when I did this with my boys, this is what they noticed. Low battery, alarm set, Wi-Fi, 2-bar cellular, the Bluetooth is on, do not disturb is on, it's charging. They noticed it was charging. It was Cole's birthday, student in the class. It's 9:02 and it's nighttime. But they wonder if the Bluetooth is on. I'm still wondering what that means. This person uses their phone a lot. Why didn't they pull their notifications? Do they have to go to work or school? How did their battery get to 5%? So you all notice and wonder the same thing that the boys wonder. But here's my wonder, all right? First of all, let me back up to notice and wondering. Noticing and wondering, I think, is a great routine when we think about equitable teaching practices. One, it brings in your funds of knowledge. It brings in your socialization. It brings in your resources. It brings your funds of knowledge. I think it increases participation while lowering risk taking. I also think it positions all students as being competent if this is something they're familiar with. The idea of competency doesn't necessarily have to sit being smart about mathematics. The idea of competency can be being able to socialize within the context of the math task and then transferring that to the mathematics. And so students can have a strong sense of identity, how they see themselves in this problem, but also agency is your identity in action. So as I move forward with this, I present my wonder. You want to know what my wonder is? At what time would the phone be fully charged? If you notice, the battery's at 5%. And if you notice, the phone is charging. So I want to know at what time will the phone be fully charged? So because of the limitation of time, I would ask you to just take a wild guess. What is the upper limit if it's 9:02 and the phone's at 5%? What would be an upper limit time that you would say? What would be a lower limit, a time that's too low? And what would be just right? And this can be just a guess. It can be just a guess. And I asked the students upper limit, lower limit, and the just right limit, just to give a range. Because I think, have you ever worked with students when they were doing a problem or doing a task and they don't have a sense of about what the answer should be? And so I want to practice that range. I want them to practice that space of what might be familiar in terms of that. So I'm going to turn it over. I'm going to ask Leslie. Is it Leslie Rouse? Leslie, I asked, my wonder was, what time would the phone be fully charged? What information do you think you might need in order to work on this problem? What information do you need? You want to ask me a question?
I need to know how fast it charges.
You need to know how fast it charges. All right. Do you need any other information, Leslie?
No.
Okay, cool. Brandon, do you need any information?
Is this plugged into like a car, or is this plugged into like a portable battery, or is this thing plugged into the wall?
Does that matter?
Yeah.
Why?
Well, if my portable charger only has 5-10% stored in it, it's really not going to charge very much, and I'm going to be waiting a really long time for that to get to 100.
See, again, here's the socialization part of this, right? It's the socialization part. Is it Charisse? Did I pronounce that correct? Charisse. Do you have any wonders?
Yeah, how old the phone is and how much is stored on it and how many apps are open.
Does that matter?
I think so, because if apps are open, I think it uses more background data. But I don't know. I'm not an iPhone person. So.
Okay. Well, cool. I mean, but again, drawing on your funds of knowledge with this. I mean, other things that my boys say, well, are you using the phone while it's charging? Who else? Do people use their phone while it's charging? I mean, all of those things come into play. I don't have any data I don't have any answer to any of those questions, but I have some data for you. Would you like some data? So notice this is at 5% and it's 9:02. Are you ready for some data? Take anything off the screen that might help you. Would you like some more data? Okay, I see some heads nodding. Take anything off the screen that might help you. Would you like some more data?
I have another wonder though.
Uh-oh. Go ahead and ask your wonder. What's your wonder?
I would like to know, is this running on the latest iOS or an earlier iOS? Because the latest iOS will pace this out and have it charge overnight and be finished charging when I wake in the morning.
Great question. I don't have an answer to your question.
Okay.
All right.
Otherwise, I just say 5:30.
Let's just assume it's going to continuously charge. How about that? Can I give you that? Let's say it's going to continuously charge. Will it charge at a constant rate? I can't guarantee that.
No, it won't.
Would you like more data? I do not have any more data, but what I've done is I've taken that, what I thought would be relevant data, put it in a table for you. I'm going to give you a little bit of time. Here's the question. At what time would the phone be fully charged? We know it's 9:02. It started at 9:02 and it was at 5%. And you see the intervals of time and the intervals of charges. At what time would the phone be fully charged? How might you use this data to come up with a solution? So let me give you a little bit of time. All right, so we don't have enough time to go into breakout rooms, but we can do this as one big rough draft talk. I don't expect you to have an answer, but I will call on some folks just to kind of help me out here, right? So can I call on Beverly Ford? You're next on my screen, Beverly. Do you have any thoughts? What are you thinking? What approach are you taking in working on this task?
So I
was figuring out like from 9:02 to 9:10, it grew by 9%, and that was 8 minutes. And then from 9:10 to 9:14, it grew 5%, but that was 4 minutes. And then I thought, there's probably a reason. So it's probably like 4 minutes, 8 minutes, 12 minutes, which makes me think about a rate. And so it makes me want to kind of figure out what that rate might be.
Ah, so you're working on a rate. Oh, wow. Oh, wow. How about you, Kimberly? What are you working on?
Something similar. I was kind of thinking of like taking the average of those three, like the 9% in 8 minutes, the 5% in 4, 14% in 12. Yeah.
All right. I appreciate that. I appreciate that. So I see, is it Flor Martinez? Am I correct on that?
Yes, you're correct.
All right. So what are you thinking?
I was kind of in the same route as the other girls. I was trying to figure out what the rate would be for 1 minute and see if it's consistent or if it's fluctuating.
Okay, cool. Cool. Did anybody say, okay, from 9:02 to 9:26, that's 24 minutes. And from 5% to 33%, that's roughly what? 28%. And so in 24 minutes, it went up 28%. And just kind of ignore the other two in between and just try to work through that. So, and the thing I love about Rough Draft Talk is that we're having these discussions. We're thinking about, because I could look at, the first and the last and trying to figure that out, or I can look at what's in between from each segment to each segment, try to figure that out to come up with some type of rate, or sometimes we can just guess, which is a legitimate strategy as well. So as I begin to think about this again, I love Rough Draft Talk just for what we just did right now, because it might implore possible solution path and how we might think about this. Again, as I mentioned earlier, Rough Draft Talk, it reduces the threat of being wrong. It allows us the opportunity to refine our thinking. It expands the status of what counts as a valuable contribution. Another strategy I use 2 drafts, 1 sheet, where I give one kind of big sheet of paper, 2 students on the same sheet, and they're working on the same task. They can do it similarly, they can do it differently. And with these boys, one of the things that we had to get over with, stop looking at my paper, but 2 drafts, 1 sheet is one of those things where one is working on one side, one is working on the other side, and they may come up with 2 different strategies, but it still makes their thinking public. So what I love about 2 drafts, 1 sheet is it positions math as a collective intellectualism. It positions learners as supportive contributors to one another's ideas, and it positions learners to work, that their work and thinking should be in the public space. Too often in mathematics classroom, math in K-12 classroom has become a individualistic kind of personal space. And how do we push math to be more public in our public space and thinking? So here's what Jude says. I just want to share one boy. Jude says, every 9 minutes is plus 10%. Then he goes on to say, I started at 8:57 because it would be 0%. So he kind of worked his way back because he went back 5 minutes, right? And so because he went back 5 minutes, that means it went down 5%, right? Then he multiplied times 90 because 9 times 10 is 90. And that's how much time it should take. So I got 1027. And that's what he got as his answer. But then he goes on to say, but I compromised with Demarion. And Demarion was on the other side of the sheet. Remember 2 drafts, 1 sheet? Who got 1025? So we did 1026 as our final answer. And so this idea of kind of this public intellectualism, the collective intellectualism comes into play. Again, the socialization and what we take up around these ideas. I didn't share this. See, these boys in 7th grade, but I shared this with them, this representation with them. And although they may not get the mathematics that underlie it, they're able to mathematize this because they become conspiracy theorists. And this is what they say. This is how Apple gets you. It charges, charge. Then they put something in your phone to make your charge slow down. Because what I love about that explanation is that somehow they're able to explain after 80 minutes and at 89%, they're able to show it slows down. They're able to see that as a slowdown, which I am so impressed by. They're able to see that there's this linear charge, this linear aspect of it, which they may not use the word linear, and they may not say nonlinear, but they are able to unpack the nonlinear aspects of this representation. And that's what I want. I want the talk and the socialization. I love that they mathematize it and claim that Apple put something in their phone to make it slow down. In fact, that claim is true. I mean, but I love the fact that they're able to have that kind of conversation around this. Although the math might be a little bit beyond the 7th grader, this nonlinear conversation that they're having is significantly important for me because I asked them, so where does it slow down? And how do you know it slows down? And if it didn't slow down, what it would look like? What if it continued? At what time would the phone be fully charged? What would it look like? I can begin to ask more math questions, digging in deeper because they notice these aspects of this. So I'm giving away the answer. 11:52, 11:22. Wow, I said 52. Wow. And so we can see how that slowdown happens here at 89, and it took for a while. And I can't remember who said something about the iOS. There's something to that, right? The thing I love about this is that we can orchestrate a mathematics discussion. And I don't know if you're familiar with the 5 practices of orchestrating a mathematics discussion, but one of the things when I think about the 5 practices, when I'm engaging in a task, I anticipate students thinking. I anticipate what are the likely responses to the task that students may have. And that's in my planning. I then monitor my students to see what their actual responses to the task may be. I then select students. I select the students based on what I anticipate what may happen because in my planning, I want some ideas to come forward. So with Jude and Demarion, I wanted them to share their idea and their thinking publicly because that was the representation I wanted to happen. And when other students share, I try to think about how am I going to sequence the different students' responses, and then how do we make connection among those things. And so these 5 practices are significantly important as I begin to thinking about the socialization. We can orchestrate discussions, although we may not know what a student may say, we can anticipate what students may say, we can monitor, and then we can select based on our anticipation on how the discussion may play out in our classrooms. And to me, these 5 practices are significantly important on orchestrating a discussion in our mathematics classroom. So when I think about instructional routines, I'm thinking about noticing and wonder. As we think about equitable teaching practices, because I want to build in socialization. I want students connected to one another. I want them invested in the task. And I take up my discretionary spaces to figure out how can I get them invested in the task. I'm not suggesting that you do this in every math classroom, but what I am suggesting is how do we then create time a couple of times a week or however often you find appropriate for your classroom to build in the socialization aspects so that students can be connected to one another and connected to the mathematics task and use their funds of knowledge. I want us to engage in rough draft talk, rough draft thinking. Again, it lowers the risk taking and increases the participation. 2 drafts, 1 sheet. Again, this idea of public sharing, collectivism. Orchestrating the discussion, and then connecting the math to the students and the students to each other. So this is where I find the socialization aspect of this work significantly important. we have about 6 minutes left, and I have way more than 6 minutes of stuff to do. So what I want to do a little bit is I just want to tag in on a couple of things. I'm skipping. You see how I'm way over playing, right? So I mentioned funds of knowledge without defining funds of knowledge. It is the funds of knowledge are those things that we bring to our classroom, that students bring to their classroom. It could be your cultural practices. It could be kind of the experiences that students have. It's a part of their daily routine. It's a part of their community. How do we have opportunities for students to bring those things into our classrooms? You know, I'm going to ask us as we think about our classroom, how do we not be gatekeepers, but be liberators for students? When I say be a liberator, what I mean by being a liberator is, you know, particularly when I think about students of color, is that how, as educators, we don't oversee a system that reifies inequity, but create opportunity that students are connected to one another. That builds in the socialization, that builds in the relevancy for mathematics. Here I have one of the things I always say to my boys, I ask them at the beginning of the day, how are you doing? And the expected response is, I am truly wonderful and getting better. And my follow-up question is, tell me something truly wonderful about yourself. And then my second follow-up question is, what are you working on right now that you're getting better at? And the reason why I do that, when I say I am truly wonderful, the truly wonderful aspect is about identity. I want to know how you see yourself in the world. I want to know how you see yourself in your classroom. I want to know how you see yourself in this space. The getting better part is just about agency. If there's something that I can identify that you're working on to get better at, then I want to connect that sense of agency to my teaching. So that conversation, so truly wonderful and getting better, it's something that it's a tagline I use quite frequently. So when I ask, well, how are you doing? The expected response is, I am truly wonderful and getting better. So I'm going to stop there. Questions, comments, thoughts, and I'm going to stop sharing my screen. And we have just a little bit of time. I see a hand. I see Tammy. Am I right, Tammy Prince?
I was trying to text, but I guess, or chat. I raised my hands now. Any ideas on how we could do this digitally during this time?
So I still think I try to model that digitally. It is difficult. I do think that breakout rooms and how we might use breakout rooms and if we're going to use breakout rooms in the virtual space, I think we have to compress the time and probably use it in multiple ways in compressing the time. And then if I'm using breakout rooms, I'm going to use maybe a Google Doc that I can see that all groups are adding to, so I can see, and then I'm jumping around from breakout room to breakout room. So the use of a Google Doc with the breakout rooms, that then that way we can still engage in the whole notion of rough draft talk and rough draft thinking, but there's some representation of that as well. I hope I answered your question, Tammy.
Yes. I've been trying to do something similar, so I really like all the things you touched on today. And the only, we're gonna go back into person shortly, but my younger kids have a harder time talking to each other in breakout rooms than my older kids. My older kids do better with it, but I do not do a doc, so that's a good idea. And have maybe, I was just thinking when you said that, have one kid be in charge of sharing that screen with everybody. So at least when I pop in, I can see what they're doing and what they're on. So that would make it quicker, because I'm usually coming in and going, okay, what'd you get? What'd you get?
Right. So, I mean, this is why I love trying to, how we create norms, because I think sometimes kids don't speak because they're not willing to take the risk. And how do we create structures in classrooms that students are willing to take the risk? And this is why I love the rights of a learner as being kind of a norm that allows students to be able to take some of those risks that we hope that they would take. All right, Paul, I went to the last minute, like you said.
Yeah, you definitely plan, even though you overplanned, you planned quite well. So I just want to thank you, Dr. Berry, for engaging us today in this important dialogue, for allowing us to do some mathematics together, and then also just for the instructional routines that can begin to really embrace that collective intellectualism and bringing mathematics out into the public spaces and sharing all the contributions we can all make to it. So thank you so much for that. Sincerely appreciate your time and your effort with us today. I also just want to highlight coming up, our next colloquium will be in April. That we will be having Marta Seville will be joining us to talk a little bit more about funds of knowledge and cultural ways of knowing in mathematics. So we'll continue the dialogue in April on the 26th. So hopefully you can all join us then. And again, Dr. Berry, one more big thank you. And thank you to all for joining us, and have a wonderful evening.
So I have one other thing for you, Paul.
Yes.
Do I send you kind of a PDF of the PowerPoint? Because I see a couple of questions that come up. I'll send it to you, and then you'll be able to distribute it. Okay,
Yep.
good. All right,
Exactly.
I'll make sure I
Yes.
get it to you.
Perfect.
All right.
All right. Again, thank you, everybody. Have a great evening.